That's Marty Edwards. He is the director of ICS CERT, C-E-R-T, which is a division of the National Cybersecurity and Communications Center. And that is part of the Department of Homeland Security. Marty, I welcome you to join us. Thank you.
Thanks, Ralph. Excellent. Well, good morning. And what a great turnout. I'm going to tell you that, Andy, thank you for turning the weather on. Most of you know I live in the Pacific Northwest, which has a little bit of snow and cold. I think last week it was about 0 at my house. So
this one goes back.
It's nice to be in 80-degree weather. It's nice to be back at the ARC Forum. This is an event that I kind of call home. It's a great combination of all the process control expertise along with industry expertise with cybersecurity people. I'm really pleased to see the cybersecurity companies coming out. So this morning they were going through some video that they had taken some sound bites and snapshots. They were asking some questions. And the question is, seems to be, are you going digital? When are you going digital? Which led me to sort of ask myself the question this morning, what is digital? And for those of you that don't know, I'm a process control guy. So some 30 years ago, I went to the British Columbia Institute of Technology in Vancouver, British Columbia, Canada, and have a diploma in process automation. Well, at that time, we were connecting 3 to 15 PSI Foxborough transmitters up to controllers. Oh, there's the phone that wasn't turned off, except that's the Windows phone, right? And I think that if we were asked then what was digital, we'd come up with a far different answer than we would now. I remember going to pulp and paper mills up in the northern part of Canada, ripping out analog PID controllers. You know, thumb wheels for set points. Now, digital seems to me to mean connected. That's what I think of when I think of digital. Because at that time, most of these loops were standalone, right? If you had a control loop in controlling anything, unless you did some pretty specific engineering and tubing in the 3 to 15 days or wiring in the 4 to 20 days, those loops didn't talk to each other. So that's kind of my premise, is that digital equals connected. Well, it's not too hard to find connectivity, is it? I know just traveling yesterday, you walk through airports, you go through traffic lights. Everything is connected to everything. And I don't think that's an understatement. And if it's not connected, it will be connected, or it's in the process of being connected. ICS CERT does, the first word, industrial, is a little bit of a misnomer, I think, these days. We do everything that isn't regular IT for the US government and for the private sector. So lately, my team's been doing a lot of work on medical devices. You know, you have an implanted medical device somewhere, pacemaker, insulin pump, medication dispenser, and it talks to a device that sits on your bed stand that's connected to the internet so that your doctor can know what your vital signs are, so that they can monitor the medications, they can monitor your heart rate, things like that. That connectivity brings some interesting questions. One of my staff sent me an email the other day that said that a police force was using data from one of these transmitters as evidence in an arson case. The individual that was allegedly the arsonist had an embedded pacemaker. The pacemaker talked to this device on his bedstand when he was at home, and he said he wasn't at home. He said, I wasn't at home fighting the fire. I was across town, restaurant with my wife, whatever the story was. And they pulled out the logs and they said, oh, but your pacemaker talked to this little device here at this time. Those are interesting implications, right? So digital equals connected. If you're not connected, you will be. That's kind of the root premise here. So now that we're connected, now we have to start thinking about security. Well, security and connected don't always go hand in hand, or at least they haven't historically. People thought of secure as air gap, right? Separate your industrial control system. Keep it off to the side. I'm not so sure that that's the right thing to do. I've seen a lot of air gap systems or a lot of one-way connected systems that the patch level is terrible. Connected or air gapped, if you're not connected, often means you're neglected. And if you're neglected, then what happens if somebody walks across the room with the USB stick and sticks it in? We know some fairly significant events that allegedly happen that way. Think Stuxnet, right? Air gap systems. So where is security going? I mean, I'm pretty impressed. I see 200 people showed up yesterday for the security track. That's fantastic. We like that. Keep coming. I see probably a quarter to a half of the sponsors or the exhibitors next door are security companies. Some of them maybe not so well known to the industrial control system folks, but more in the IoT, the Internet of Things landscape, right? So we've got a lot of emerging technology. 10 years ago, if I was standing here telling you this, and I left my sort of day job as a senior controls engineer 10, 11 years ago and came into the security field, we would have been preaching to you about how you cannot, absolutely should not, use any IT security methodology in your control system because you'll break it, right? Remember the old sort of reports of a ping scan or a ping sweep of a set of controllers would make your PLC go offline, would make robots move around by themselves. That's what we were talking about in those days. I actually think that there is a great availability of industrial control system or IoT type specific security solutions now. So what I would say to you is that, make sure you're looking at some of that new technology. There are vendors that are in this room that have invested millions in developing new product lines and hardened product lines that contain security from the ground up. I think it's a good day for security in the control system environment. Lots of tools to choose from, hardened products that are going to come secure by default out of the box, right? And you might have to have some configuration to make it work with legacy types of systems, right? And have some sort of border protection or perimeter kind of protection where those points of connection are. But overall, I think this is a good message. Okay, so now we're connected, right? I said digital was connected. Now hopefully we're connected securely. We've all done our due diligence and applied the appropriate amount of security, I hope. Well, what is that due diligence mean? I mean, what do we still see? So I'll take a little sidecar here. I would say that the number one challenge that we still see, and quite frankly, ICS CERT takes some heat sometimes for not necessarily being the most innovative, right? It's like we're still out there talking about perimeter protection. We're still out there talking about patching levels. We're still talking about inadequate logging. Well, that's because that's what we find. I'm not going to start talking about, some super, new secure protocol until I can at least get people to continue to do the basic sort of daily hygiene in the cybersecurity area. When my team goes out and does assessments of either federal or commercial facilities, in any sector, the biggest thing that always comes up is lack of perimeter protection. In many cases, there is no perimeter. That blows me away still, actually, that you would have your control system and your PLC still connected to the same network that you're running email clients on. At least do some separation, right? At least do some segregation. And please don't tell me that you're using a VLAN for security separation, okay? So network 101, right? Yes, you can use a virtual local area network on any manufacturer's switch and router set to divide the networks logically. In many cases, if there's weaknesses in that switching topology, you can jump from VLAN to VLAN, so not secure. Okay. So you've done all this due diligence, right? You've got everything in place. You're patching your systems. You've got great perimeter control. Your people are all trained. You've got logging devices on all your control system segments, networks. You can tell me when I come in to help you with an incident, this is who logged on. This is what remote access node they were coming from. Here's their credentials, their user privileges. It's all logged, right? Yeah, not so much. So if we're all connected and we've all done our due diligence, I still believe that if you have an adversary that is looking to do something to you and they are well-funded and well-informed, that it really doesn't matter that you've done all this stuff. I think that you need to continue to do that base level of security, that base level of engineering how you've connected everything. But at the end of the day, if you're dealing with a nation state or an advanced organized crime group that wants to penetrate your system, they will figure out how to do it. Through people, insiders, technology, they will figure out how to do it in the most hardened of systems. And we just have to look inward at various data breaches over the years. And the US government's not immune to this either, right? Massive data, personally identifiable information, massive PII data breaches. We only have to look at the resurgence of things like Shamoon, the Ukraine events, right? The power outages in the Ukraine. All of these things came about because of this interconnectivity. And I think you could argue that some of them were enabled by not necessarily the best practices in cybersecurity, right? Well, I'm going to pitch a concept this morning that has been talked about for a few years, and I'm going to tell you that I'm quickly drinking the Kool-Aid. Some people call it cyber-informed engineering. Basically, what this entire concept is in your facility, I don't care what sector you're in, find that most critical of functions. In a chemical plant, and I worked in specialty chemical for a number of years, that may be some exothermic or highly reactive reaction that the feedstock, it's going to run away by itself. You need a proper shutdown procedure to protect yourself against that. It could be something like in the Aurora generator test we did in 2007, connecting a generator out of phase at high speed to its power grid. Find that basic function and then take it offline. Sounds kind of funny to have a security guy, a cybersecurity guy, talking in a conference about connectivity and digital, and I'm trying to persuade you to take those offline. Now, I'm going to tell you that if you have found more than one, or maybe two, of these functions in an entire plant, you've done it wrong. You need to find that one thing, right? I still remember in the specific chemical plant that I did some work in, there was essentially two halves of the plant isolated by a long pipe bridge, and that pipe bridge had some valves that once closed required being pulled out of the line to open back up again. Those isolation valves were to keep the problem, fire, whatever issue, in the respective side of the plant. It's the red mushroom button, right? It's the button on the wall that's by the exit door. As you're running out, you push that button. And once you push that button, it can't be unpushed, right? It's going to require a maintenance action to bring everything back. I've seen these functions, these types of safety functions, become computerized, digitized in Andy's vernacular of this conference this morning. And I actually propose that that's not a good thing in all cases. We need to actually take those kinds of functions, very carefully engineer them, and take them offline. Now, for my press friends in the audience, and I know there are a few of them because I know you personally, I've heard this mischaracterized in some of the national press level because there as dumbing down of the smart grid, something like that. And I would tell you that as somebody who comes from the engineering industry, I couldn't think that statement is further from the truth. I think this is sound engineering principles that we are applying the right level of technology, the correct level of technology, to a problem to solve the problem in that most basic way. Now, some of these shutdown functions aren't necessarily simple, right? I know why they have been digitized in some cases, and it's because they're very complex. Okay, well, we have tremendous manufacturing capability. There's nothing wrong with picking and choosing what technology you use. Just don't make it reprogrammable, right? Sure, you're going to have supply chain protection issues, but those are, I'm going to tell you, it's a lot more difficult to breach a supply chain than it is to penetrate a connected system with a poorly configured perimeter and zero patching, right? So build specialty circuits for these functions if they require that level of capability, right? So, and do this very diligently. I mean, look at these functions, find the one or two of them that's in each plant. In the boiler control world, and I did a lot of boiler control for some reason, maybe it's because almost every plant has some somewhere. You know, we used to take, and that red button used to disconnect the power to all the I/O subsystem. So basically everything went to its fail-safe position. I'm worried. I have enough gray hair now, I guess, that I see the newer engineers and the newer technologists that are coming out and applying these skills, and their first default is to go to this off-the-shelf, whether it's a programmable automation controller or a PLC or whatever. They want everything programmable. I do it myself, right? It's easy. We know how to deal with the tools. It gives us great benefit to interconnect all these devices. But I'll tell you that, you know, we do need to take care of those most basic safety and life safety and equipment protection functions in this industry. And I think we can do it. Now, I'm also going to say that doesn't mean you can stop doing the basic cybersecurity stuff, right? You've still got 99.9% of the control functions out there that are in this enabled, connected, digital architecture. And you need to go through with a proper risk assessment methodology, and there are several you can pick from, to figure out where are, you know, those things that you need to protect most. You know, we often go into companies and so where are the crown jewels at, right? What is of value for your company? In some companies it's intellectual property, in some it's scale of manufacturing, the ability to build lots of things inexpensively. Find out what that is and protect it. It's simple, right? You don't need to protect everything. If you try to protect everything, you're actually probably going to protect nothing, because there's such a scale here. Go into you know, in the old days, we talked about, you know, several tens of thousands of I/O points in a factory being big. Well, these same plants now are hundreds of thousands or millions in big campuses. If you try to protect every single controller box or every single PLC or every single HMI to the same level of protection, you're going to have a small army of cybersecurity individuals, right? So scale it, right? Pick the most important things. Protect those most important things with the right level of countermeasure, right? And in some cases, where the consequences are just not acceptable of any type of mistake, build in that physical, redundant, offline, non-reprogrammable, however you want to paraphrase it, but find the red button, right? You know, figure out what that one loop is, or two, maybe. Anyway, thank you for coming. I will be around on the executive panel here a little later today. I'll also be walking around. Come talk to me. This might not have been the talk that you expected to hear from the government security guy who's saying, go and unplug your stuff. Right? I'm going to call my talk Marty Unplugged from now on. But I think it's important. And there's a few people around in the industry who are thought leaders who have convinced me that it is important. So let's do this together, right? Let's figure out how to move forward and how to make sure that these plants are safe and secure for our kids and their kids. Thank you for listening.